In 2022, a telescope the size of a tennis court unfolded itself in the darkness of space, pointed at a grain of sand-sized patch of sky, and sent back images that made scientists go completely silent. Not the good kind of quiet. The kind where someone reads a number twice, then a third time, then closes their laptop and stares at the wall. What the James Webb Space Telescope discovered out there isn't just surprising. It is deeply, viscerally unsettling. And once you understand what it actually means, you will never look at the night sky the same way again. The telescope that changed everything. Let's start with what this thing actually is. Webb launched on Christmas Day, 2021. It carries a primary mirror nearly 7 meters across, made of 18 gold-coated hexagonal segments that had to fold like origami to fit inside the rocket, then unfold perfectly in deep space. For comparison, the Hubble Space Telescope's mirror is 2.5 meters wide. Webb's is more than double that. But size wasn't the real breakthrough. It was sight. The universe is expanding. Light from the earliest stars and galaxies has been stretched over billions of years, shifted out of the visible spectrum, deep into infrared. Hubble could see far. Webb was built to see further into the part of the universe's story that had never been read before. To do this, its instruments operate at roughly -223 degrees Celsius, colder than anything in our natural solar system. A 5-layer sun shield the size of a tennis court keeps the telescope's own warmth from blinding it. Engineers identified 344 individual points of failure during deployment. Any single one could have ended the mission. Every single one succeeded. Then Webb opened its eye, and what the universe said back made scientists deeply uncomfortable. Galaxies that shouldn't exist. This is already getting strange. Smash that like button and subscribe, because it gets much stranger. Webb's first deep field image dropped in July 2022. In a patch of sky the angular size of a grain of sand held at arm's length, it revealed thousands of galaxies, including ancient objects no telescope had ever clearly seen. Researchers expected to find young, small, dim, chaotic galaxies in the early universe. The early cosmos should have been a rough draft. Messy, thin. Instead, they found cathedrals. Fully formed, massive, structured galaxies blazing with light when the universe was only a few 100 million years old. Then came the truly disturbing part. In early 2023, researchers identified 6 galaxies that formed within the first 500 to 700 million years after the Big Bang. Their stellar masses ranged from 10 billion to 100 billion, times the mass of our own Sunday. The Milky Way contains roughly 60 billion solar masses, and our galaxy took billions of years to build itself up. These 6 objects supposedly did it in a fraction of that time, during what should have been the infancy of the universe. Under every known model of star formation, reaching that mass would require nearly 100% of all available gas converting into stars. Essentially, perfect efficiency, which physics says is impossible. One researcher put it plainly: these galaxies should not exist. The most distant thing ever confirmed. On the 30th of May 2024, scientists announced the most distant confirmed galaxy ever identified. Its name is JADES GSZ 140. Its light left home when the universe was only 290 million years old. It already contained hundreds of millions of solar masses worth of stars. But here's where it gets philosophically staggering. In March 2025, researchers detected oxygen in that galaxy. Oxygen is not a primordial element. It was not created in the Big Bang. Oxygen only exists because stars fuse it inside their cores over millions of years, then explode in supernovae, scattering that oxygen into surrounding space, where it eventually gets absorbed into the next generation of stars, planets, and lungs. Finding oxygen in a galaxy only 290 million years old means that before that galaxy even existed in the form we see it, entire generations of stars had already been born, burned for millions of years, died, and seeded the region with heavy elements. All of that stellar birth, stellar death, chemical enrichment of an entire galaxy crammed into a window of time astronomers previously considered nearly empty. The early universe was not slow. It was not dim. It was burning faster, harder, and more chemically complex than anyone had a right to expect. Black holes that break the rules. Galaxies weren't the only shock. In 2024, astronomers confirmed a supermassive black hole inside a galaxy when the universe was only about 400 million years old, with a mass of roughly 1.6 million suns. In today's universe, a galaxy's central black hole typically weighs about 0.1% of the galaxy's total stellar mass, a small, dense anchor. These early black holes were completely different. Some weighed 30% or more of their entire host galaxy's stellar content. The black hole wasn't a small anchor. It was almost as heavy as the galaxy itself. Astronomers called them little red dots, compact, intensely bright objects scattered across the early universe in numbers 10 to 100 times greater than any model predicted. Nobody has a clean explanation. One possibility: these black holes didn't grow slowly from smaller seeds. They may have collapsed directly from massive clouds of gas, bypassing the normal process entirely. Another possibility: they were consuming matter at rates that break known physical limits. Whatever the answer, the early universe wasn't just building galaxies impossibly fast. It was also growing monstrous black holes, somehow, impossibly quickly. The expansion problem, nobody can solve. Zoom out even further, and the problems keep multiplying. Scientists have two methods for measuring how fast the universe is currently expanding. When they use signals from the early universe, they get approximately 67 kilometers per second per megaparsec. When they measure using local galaxies and supernovae, they consistently get about 73. Webb has since independently confirmed the local measurement, ruling out simple instrument error. Two different methods, two irreconcilable answers. The gap between them, called the Hubble tension, has no agreed solution. One of those numbers, or possibly both, is missing something fundamental about how the universe works. And then there are structures like the Hercules Corona Borealis Great Wall, a cosmic structure potentially spanning 10 billion light-years. Standard cosmology says the universe should become smooth and featureless above roughly 1.2 billion light-years. A structure 10 times larger than that limit, if confirmed, means one of our most basic assumptions about the universe is simply wrong. 3 ways. Everything ends. Dark energy, the mysterious force accelerating the universe's expansion, makes up roughly 68% of everything that exists. Ordinary matter, the stuff you're made of, is only about 5%. For decades, scientists assumed dark energy was constant, stable, a permanent pressure woven into the fabric of space. In April 2024, a survey mapping over 6 million galaxies suggested dark energy may be changing, weakening, possibly, over cosmic history. If true, the universe's final chapter is no longer certain, and 3 endings remain mathematically possible. If dark energy stays steady, everything eventually fades. Stars burn out, galaxies drift beyond each other's horizon, black holes slowly evaporate over timescales that make the current age of the universe look like a first heartbeat. Heat death. Silence. If dark energy strengthens, it eventually overcomes every other force. Galaxies tear apart, then solar systems, then planets, then atoms themselves, shredded at the quantum level. The Big Rip. And one 2025 model suggests expansion could eventually reverse the universe, contracting back over a total lifetime of roughly 33 billion years into something resembling what came before the Big Bang. A big crunch. We don't know which ending is coming. And here's the truly haunting part we may not be able to know. The further the universe expands, the more evidence disappears beyond our observational horizon. Future civilizations, billions of years from now, may not be able to see enough of the universe to even reconstruct the Big Bang. The data will simply be gone. What this all means: Webb wasn't just built to take beautiful pictures. It was built to test our standard model of cosmology, the framework describing how the universe formed, grew, and where it's going. And what Webb found, observation after observation, is that the standard model is straining. Galaxies too large too early. Black holes too massive for their hosts. Structures too vast for standard predictions. An expansion rate that refuses to resolve. Dark energy that may not be constant. We live right now in a narrow window of cosmic history, where light from the universe's earliest moments is still reachable. Webb arrived in exactly that window. And what it keeps saying clearly, across discovery after discovery, is this. We understand far less than we thought. Not zero, but far, far less than a century of confident physics suggested. And somewhere out there, in a galaxy that formed 290 million years after everything began, there is oxygen made inside stars that lived and died before that galaxy fully formed, waiting patiently for us to understand why it's there. Which part unsettled you the most? The impossible galaxies, the oxygen, or the three ways everything ends? Drop it in the comments. I read every single one. If this changed how you see the universe, share it with someone who thinks science has everything figured out. Like, subscribe, and hit the bell. Because we're just getting started. See you in the next one.